What if most of the universe is invisible? Something that should be impossible, unless there was massive unseen matter pulling on them. Her data confirmed Zwicky's suspicion. Most of a galaxy's mass isn't visible at all. The cosmic glue holding everything together. Imagine throwing glitter into the air without gravity. It would scatter and drift apart. Galaxies are no different. Without dark matter, they wouldn't have enough mass to hold themselves together. It's like there's an invisible hand cupping every galaxy, keeping its stars in orbit. Without that invisible glue, the universe would look entirely different. A chaotic mess of scattered stars and shredded cosmic fragments. Dark matter acts as the scaffolding of the cosmos, an unseen skeleton that defines where galaxies form, how they cluster, and even how they evolve over billions of years. When scientists simulate the early universe on supercomputers, adding dark matter to the mix perfectly recreates the cosmic web. We observe vast filaments of galaxies stretching across unimaginable distances. Remove dark matter from the simulation, and the universe collapses into a formless haze. The evidence. We can't ignore it. We might not be able to see dark matter directly, but its fingerprints are everywhere. Galaxy rotation curves. As Vera Rubin proved, galaxies rotate far faster than visible matter can explain. Gravitational lensing. When light from distant galaxies bends around massive clusters, the amount of bending shows there's far more mass there than we can see. Cosmic microwave background, CMB, the faint afterglow of the Big Bang, carries subtle patterns that perfectly match the presence of dark matter in the early universe. Galaxy collisions. In events like the Coma Cluster, two galaxies collide and separate. The visible gas slows down, and invisible mass passes right through. This is the smoking gun of dark matter's existence. All of this adds up to one unavoidable conclusion. Something invisible is shaping the cosmos. What is dark matter made of? Now comes the big question. What is dark matter actually made of? There are several leading theories. WIMPs, weakly interacting massive particles. These are the top candidates, heavy, invisible particles that barely interact with normal matter. Axioms, ultralight particles that could explain dark matter as a vast, gentle field spread across the universe. Sterile neutrinos, a mysterious cousin of the neutrino that interacts even less with normal matter. Primordial black holes. Tiny black holes formed right after the Big Bang could account for some dark matter, though the evidence is uncertain. Every major particle accelerator, like CERN's Large Hadron Collider, has searched for dark matter particles, but so far nothing. Every deep space telescope has looked for its glow, but found only silence. And yet scientists refuse to give up because the gravity never lies. Why finding it matters? You might wonder if we can't see it, and it doesn't affect our daily lives. Why does dark matter even matter? Because understanding it could rewrite everything we know about physics, cosmology, and existence itself. If we find what dark matter truly is, it could open doors to new forces, new particles, or even new dimensions. It might reveal why galaxies formed the way they did, why the universe expands as it does, and why despite all our knowledge we still understand only a tiny fraction of reality. Dark matter could be the missing link that unites the two biggest theories in science, quantum mechanics, and general relativity. The key to a theory of everything. The hunt beneath the Earth and beyond the stars. The search for dark matter is happening everywhere from underground laboratories to space telescopes. In Italy, the Gran Sasso Laboratory sits buried beneath a mountain, shielded from cosmic rays. There, detectors filled with liquid xenon wait patiently for the faintest flicker of a dark matter particle colliding with an atom. In space, NASA's Fermi Gamma Ray Telescope scans the sky for strange signals, hints that dark matter particles might be annihilating each other in the darkness. In Switzerland, the Large Hadron Collider smashes protons together at nearly the speed of light, hoping to momentarily create or detect one of these elusive particles. And across the globe, physicists, data analysts, and astronomers all chase the same ghost, something that may exist everywhere, and yet nowhere at all. New theories, new mysteries. Despite decades of research, dark matter remains hidden, so scientists have begun thinking far beyond the ordinary. If dark matter isn't made of traditional particles, maybe it's something entirely new, a different kind of physics waiting to be discovered. Some believe dark matter could be a shadow version of our universe, a mirror world, filled with its own forms of atoms, stars, and even life, but completely invisible to us. According to this idea, there might be an entire mirror cosmos overlapping ours, interacting only through gravity. It's a haunting concept that somewhere, right beside us, another universe moves in perfect silence. Others suggest dark matter might not be matter at all, but a sign that our understanding of gravity itself is incomplete. The modified Newtonian dynamics, our OND theory, proposes that gravity behaves differently at vast cosmic scales, eliminating the need for unseen mass. If true, it would mean we've misunderstood one of nature's most fundamental forces for centuries. But so far, no alternative theory can fully explain the wealth of evidence dark matter leaves behind. Something is out there. We just haven't caught it yet. The shape of the invisible universe. When astronomers map out galaxies across billions of light years, they don't see chaos, they see a pattern. A cosmic web, long filaments of galaxies connected like neural pathways, forming a vast, interconnected structure that fills the universe. These filaments are not made of visible matter, they're formed by dark matter. Like scaffolding, it shaped where galaxies would grow after the Big Bang. Imagine the early universe, a hot glowing soup of particles and radiation. As it cooled, dark matter began to clump together under gravity, forming invisible halos. These halos became the seeds of galaxies, pulling in ordinary matter, gas and dust that would ignite into stars. In a very real sense, we owe our existence to dark matter. Without it, the Milky Way might never have formed, the Sun might never have been born, life on Earth might never have existed. The cold, the warm, and the hot. Dark matter isn't just one idea, there are temperatures of it, based on how fast the particles move. Cold dark matter, CDM, slow-moving. Heavy particles, the most accepted model today. It explains large structures in the universe perfectly. Warm dark matter. Medium-speed particles could explain smaller cosmic features, like dwarf galaxies. Hot dark matter. Fast-moving particles, like neutrinos, once thought to be the answer, but they can't clump enough to form galaxies. Cold dark matter rules the current models, but even it struggles to explain a few cosmic puzzles, like why galaxies have fewer satellite galaxies than expected. Every model brings us closer, but none are complete. Dark energy, the partner in mystery. If dark matter makes up about 27% of the universe, another mysterious force called dark energy makes up roughly 68%. Together they dominate all of existence. While dark matter pulls things together with gravity, dark energy does the opposite. It pushes the universe apart. It's the invisible force driving the accelerating expansion of the cosmos. Scientists believe these two might be connected two faces of a deeper, unknown reality. What if dark matter and dark energy are not separate at all, but manifestations of a single, unified phenomenon? Something so fundamental we can barely even conceive it with our current physics. The deeper we look, the more it seems the universe is built on invisible foundations, and we're only scratching the surface. The cosmic labyrinth, experiments on the edge of reality. Around the world, vast experiments continue to probe the dark. In South Dakota, the LX Zeppelin experiment, one of the most sensitive dark matter detectors ever built, sits buried a mile underground, surrounded by rock to shield it from interference. Inside, thousands of gallons of liquid xenon await the faintest flash of a dark matter particle colliding with an atom. In Japan, the Super Kamiokande detector uses ultra-pure water and light sensors deep inside a mountain, scanning for ghostly signals that might hint at dark matter's presence. And in outer space, telescopes like Euclid and James Webb map the invisible skeleton of the universe, revealing how dark matter bends light and sculpts galaxies. Each experiment brings us closer, but the silence is deafening. Every year that passes without a detection raises a haunting question. What if dark matter doesn't want to be found? Because we're asking the wrong questions. The unthinkable possibility. Some scientists have begun to consider an unsettling idea. What if dark matter is not from our universe at all? The concept of extra dimensions proposed by string theory suggests our universe could be a 3D surface, floating in a higher dimensional space. Dark matter could exist in one of those other dimensions, its gravity bleeding into ours. In that case, we're not chasing invisible particles, we're chasing the gravitational echo of another reality. Something beyond the limits of human perception, bleeding into our world only through gravity. It's science, but it feels like philosophy, even theology. A mystery that connects the smallest quantum fields with the grandest cosmic structures. Dark matter and the future of humanity. Understanding dark matter isn't just about curiosity, it could shape humanity's future. If we can harness its properties, it might open doors to new energy sources, gravity control, or even faster than light travel. It could redefine technology the way fire or electricity once did. But there's a deeper reason, one tied to meaning itself. The search for dark matter represents something uniquely human. Our refusal to stop asking questions, to stare into the darkness, knowing it might never answer, and still, to look anyway. This pursuit is not just about science, it's about who we are as a species. Curious, restless, reaching beyond the visible. The coming decade, the moment of truth. We stand at the edge of discovery. With the next generation of telescopes, the Vera Rubin Observatory, the Nancy Grace Roman Space Telescope, and the Dark Energy Spectroscopic Instrument, we may finally detect the cosmic fingerprints of dark matter. Some scientists predict the answer could come within the next decade. Others warn that it may take another century. Either way, the truth is waiting, hidden not in the light, but in the dark. Outro, the universe we can't see. Yet, look up at the night sky. Everything you see, every star, every galaxy, every flicker of light is just a thin film floating on an invisible ocean. That ocean is dark matter. It binds the cosmos together, whispers through the void, and holds the story of creation itself. Maybe one day, we'll finally see it. Maybe we'll even learn that we've been living inside it all along. Until then, we keep watching, we keep searching, and we keep believing that every mystery, no matter how dark, brings us closer to understanding who we truly are. Subscribe and stay curious. If you love diving into cosmic mysteries, from dark matter to alien worlds, hit that subscribe button, because the universe has secrets, and we're here to uncover them one story at a time.